Hello, dear listening or the conference. I present to you my work selection or the optimal processing mode for cast and deformed types alloys to shape memory effect. Ensuring the high quality of mechanism for the entire service life by increasing the reliability and tightness of components elements is one of the most important tasks of mechanical engineering and robots, as well as long-term goals of the industry. One of the main factors for ensuring reliability is the use of new materials with specific properties, such as the shape memory effect. Then using such materials, the quality of products depends fundamentally in the level of technology, the improvement of which can be achieved through the develop and implementation of such process in which human participation is limited and is mainly reduced to the management. The peculiarity of the alloys with the shape memory effect is what the works in the performed by the materials itself due to the generation of internal stress then the crystal lattice changes. Such properties of the alloys can be used, among other things, than fractionating in neural networks in adaptive control problems and as algorithms of robots. As the conducted studies have shown, the alloy of titanium nickelite with the free elements alloys reducing the temperature of the Martensite transformation to cryogenic temperature. One of the alloys is alloys based on the titanium nickelite doped with iron. The alloys has recently attached attention as materials for the manufacturing element of permanent connection of the pipeline using the processing of thermoplastic memory. In order to determine the temperature range of pressure treatment of alloys at different temperature, which allows us to establish the temperature range of maximum plasticity 700 1000 degree to 1100 above 1000 brittle described in the simple is observed, which indicate the melting of intermetallite titanium to nickelite titanium nickelite free located along the grained boundaries. It is observable to deform the cast metal of the nickelite at a temperature no higher than 1100. On figure 2 shown the mechanism properties at different temperature of the precious nickelite alloys. The maximum elongation it's about 85% of the alloys has a temperature of 1000. Temperature rise to 1100 leads to the slight decrease in the plasticity characteristics. Comparison with the curves in figure 1 shown the deformed material has a greater margin of the plasticity at above height and low temperatures. Production and research of pressed rods made of nitinol alloys. Nitinol ingots were had for the pressing to a temperature of 1050 in order for the metal to be heated evenly. The ingots were placed in a oven at the temperature of 500 to 600 degrees and were heating together with the furnace at the speed of up to 15 degrees an hour to a temperature of 1000 to 1050. Served at this temperature for 5-6 hours and then pressed at different pressing speeds. During heating and exposure, the process of galvanization of titanium takes place, during which there is a partial dissolution and coagulation of excess phase. Instead of the continuous layers, rounded disperse inclusion remain along the grain boundaries, and the plasticity of the cast material increase. The increases in plasticity as a result of galvanization allows to increase the degree of compression during pressing. During the pressing process, the grain crushed and the inclusion of the face dispersed even more. The production of the workpiece, according to the technology, provides a satisfactory surface. The absence of crack and delaminations, galvanization structure, and mechanical properties. The relative temperature and deformation modes of manufacturing pressing bars, there are determined then the pressing bars of various diameter on the pressure of 1000 tons and 5000 tons. On a pressure of 5000 tons, a blanks of 230,10 millimeters has pressured from 2040 millimeters container. The blends were placed in the alignment furnace at the temperature of 300 degrees and heated with an hour to 9030 to 9060 degrees, 1000 to 1020 degrees, and 1050 to 1080 degrees. Exposure at this temperature was carried out of up to the 3 hours. Pressing was carried up as a speed of more than 30 millimeters per second and less than 60 millimeters per second. Upon visual inspection of the bars, it was found that the bars heating about 1000 degrees, if and pressed at the high speed, they have cracks on the surface, reducing the heating temperature to 880 to 900 degrees. Then pressure bar leads to under pressure of blanks. When developing temperature and deformation parameters for manufactured bars with a diameter of 20 to 14 millimeters, blanks with a diameter of 110 millimeters were pressured for the content with a diameter of 115 millimeters with a degree expansion of 8 to 25%. Present was performed at a different speed, about 60 millimeter per second and 30 millimeter per second, and third its speed it's more than 30 millimeter per second. Then present rods with a diameter of 110 millimeters at diameter 30 and 22 millimeters at temperature of 100, 150 and 155. It was found that a good quality of titanium nickelite alloys rods with a diameter of 30 millimeters obtained when they are heating to the temperature of 1030 and pressure at the speed of 30 millimeters per second at highest temperature. Metal overheating has observed. The quality of bar diameter 22 millimeters is similar to bar diameter millimeters. It's about 40. The mechanism properties along the length of the rods are quite informed. It's a figure 3 with an increase and the degrees of growing. The volumes of stretch and plastic increase, which is associated with a grinding. It's a figure 4. The study of the macro and microstructure of the pressure rods of the various diameter, as well as the mechanism properties, indicate that the selected temperature and deformation mode of process then nitinol to obtain bars of good quality. It's a figure 5. The height hierarchies or the parameters alloy with titan nickel based, it's the shape memory effect, such as the degree of recovery, the developed forces, the amount of accumulated reservoir deformation with increased plasticity, height corrosion resistance, determine the prospect of its wide application in engineering, ensuring height and stable thermomechanical characteristic on titanium nickelite in specific devices over the entire operation, temperature range recurring, and ability to vary the parameters of shape memory effect and superplasticity with a wide range. The scientific approach to solving which problem is to clarify the nature and the mechanism of the manifestation of shape memory effect on the basis of the deep studies of the properties of the materials, and the USA, Great Britain, Japan, and in other countries, such materials have found mass application in aerospace and shipbuilding equipment. However, the manufacture technology of such part is hidden, and the parts made of the alloy with shape memory effect, nitinol, and supplied ready-made. In this paper, the technology, temperature, and deformation models of operation of the alloys with shape memory effect, it's nitinol, providing operation temperature above cryogenic, very investigated and presented. The effect of nitinol doping on the temperature and deformation regimes and the generation on internal stress and the alloys with shape memory is shown. In the course of works, it was found that the optimal mode of deformation of the cast alloys nitinol, its hot present at the temperature of 151,100 with preliminary exposure at this temperature for 5 to 8 hours. Then pressing bars from pre-deformation nitinol, the best quality of the metal is provided at the deformation temperature of 1030 degrees, the deformation rate of 30 millimeters per second with a degree of extraction from 8 to 25%. As was noticed earlier, the works on the deformation of the part is performed by the materials itself due to the generation of internal stresses. Then the crystal lattice changes. The result obtained allows us to make parts from an alloy with shape memory effect nitinol taken in into account all the features of nitinol. They allows you to get parts with operation temperature below minus 60 degrees, which is necessary for the mechanism of aviation and rocket and space technology. Further study of the properties of nitinol, such as the shape memory effect and the unique property of superplasticity, allows us to improve technology and apply such alloys in various industries, including robots.